All right, in the last lesson we played our sort of guessing game where we figured out, but through a process of trial and error really, what our function needs to be to make a given graph. Here, we're doing something really similar. It's just a little bit less forgiving. So here we have to figure out sort of from scratch what the function should be to represent the graph. Okay? So our goal is to find f of x, where f of x is this guy's curve, right? The first question, step one, we need to decide, and we never had to decide this before in the last lesson. Do we want to use sine or cosine? Mercifully, we're not worried about tangent or secant or any of those just yet. But we need to figure out which is which. Well, let's take a look at our unit circle, and that's going to help us make this call. So on our unit circle, we're going to look at this little spot here. So this says cosine of 0 equals 1 and sine of 0 equals 0. Okay? So what this means, right, is that cosine has a peak at the origin. So cosine kind of looks like this. Sine has a 0 at the origin. So I kind of missed there, but sine goes through the origin just like that. Okay? So for our particular graph, notice it doesn't go through the origin, and it has this peak here. So this peak here at the origin tells us that cosine is a good starting spot. Okay? So similarly, if I had sort of this middle piece at x equals 0, I would use sine. Okay? So that tells me that my function here is going to be cosine of something x. Maybe plus something, maybe minus something. Right? So that's our first determination we need to make. And we'll do a couple of examples so you can see what a sine example looks like here in a second. So I've decided on cosine for this graph. I just brought this graph down in the next page, by the way, because it has a peak at the origin. So it's a cosine graph. Now, let's think about the amplitude. So I'm going to have f of x equals cosine of something x plus something maybe. I want to find the midline. So I'm going to draw a line through the center of the graph. Not the center of the graph, the center of the wave, I guess. And I notice that that center is at -1. Okay? So I know that I'm going to subtract 1 after everything here. So that's my midline. Okay? Now I want to worry about, let's do amplitude next. So remember, our standard amplitude is from 1 to 1. So our standard amplitude is 1. This graph has an amplitude of 3, right? So any peak or trough that I pick is 3 units above that midline. That tells me I should multiply times 3. So last thing, and the hardest thing, is the graph's period. So I'm going to notice here that a full sort of revolution or a full wave here, I'm always going to count from peak to peak, I think is the easiest way to do it. So I'm going to find my first peak, and then I'm going to go to my next peak to the right. What I notice here is that is 4 pi, right? Okay, so there's a couple of different ways you can think of this. What I like to do is I like to use a little formula. Actually, I think it's the easiest way. So my formula is going to be 2 pi divided by the period, and that's going to go right here. So in our particular case, we have 2 pi divided by 4 pi. Okay? That gives us obviously 2 over 4, 1 over 2 is 1/2. So that's what goes here, and that's my period. Okay? Or this is often called the frequency, actually, is the better name for it. So we could say frequency equals the period underneath 2 pi. Okay. Another way you can think of it is, for this example, some of you may find this easier than memorizing the formula. Some of you may find it harder. It depends on how your brain works. Remember, the normal period is 2 pi. This is twice as big, meaning it's going half as fast. So it's kind of the reciprocal of what we're multiplying it by to stretch it out or shorten it, right? So 1/2 x doubles the period. 1/5 x would be 5 times the period, and so on. Okay. Similarly, like if I put like 5x here, my period would be 5 times shorter. Okay. So you can think of it intuitively like that, or otherwise, this is your formula. And then this is my function. So I have my frequency or my period here, my midline, and remember this 3 was my amplitude. Okay, and we'll do one more example. So here's my second example. And we'll notice this is a sine graph this time, and here's why. So at x equals 0, notice we're in the center of a wave and not at one of these peaks, right? So that tells me this is a sine function. And then we can worry about the midline next. I'll switch colors for all of these this time. So you have a really good example here. So my midline is here at y equals 2. So we're going to do plus 2 for my midline. My amplitude, well, it seems to be 3 again, right? Green for the amplitude. So my amplitude, is the distance from the midline to my peak or my trough, and that is 3 units. So we'll throw a 3 in front of our sine function to make it 3 times taller. And now we need to figure out the length of one full rotation. Okay, so I like to go from peak to peak. So here we go from negative pi over 2 to pi over 6 to peak. Oops, I should have switched colors there. So that's going to help us figure out our last parameter here. Okay. And let's see. So this is a good example because it does not line up nicely. So one way you can always figure it out, right, is by subtracting. So you could do pi over 6 minus negative pi over 2. And so we're going to treat these like fractions, right? So essentially we could treat it as 1 over 6 plus 1 over 2. And we know that that is the same as 3 over 6, right? So we're going to get 4 pi over 6, which is the same as 2 pi over 3. And that's my period, right? So from peak to peak is 2 pi over 3. And remember, this one is a good one to use the formula on because it's harder to do it in your head, right? So we'll do 2 pi over 2 pi over 3. Okay. And by the way, if you don't like adding fractions or subtracting fractions, you could have done that on your calculator just as 1 over 6 minus negative 1 over 2 and use the fraction function. And then you can just tack pi on at the end if you weren't able to do that in your head. Okay. And then when I divide, well, speaking of things you could do on your calculator if you don't like fractions, so my 2 pi and my 2 pi cancel out. I'm left with, you can do it like this, 1 over 3. And then remember, dividing by this is the same as multiplying by the reciprocal. So 3 times 1 is just 3. And again, that's a fair thing to do on your calculator as well. But that is our last parameter, 3. And that would give me a period of 2 pi over 3.